Hello guys, you're welcome to my next tutorial, and today we're going to be looking at the famous Quicksort. I'm so excited because Quicksort is very interesting. I'm sure that you also will discover so. Now let's look at Quicksort is one of the sorting algorithms that we have. Let's say for instance we have an array that contains this set of numbers, and we need to sort this array such that we have the numbers arranged in non-decreasing order. Non-decreasing meaning that they can be the same or they can be in increasing or what you call ascending order. So what's the procedure for Quicksort? Quicksort is basically divided into two parts. The first part, which is a major place where a lot of work is done, is on the partitioning. You partition on a pivot, you return the pivot, then you call Quicksort recursively on your left and your right partition. Take for instance, select a pivot where partition is. Select a pivot at the first element, and you can decide to select a pivot at the middle or make your last element at the pivot, or you can decide to do a median of the first, the middle, and the last element, and take the median of those three and use them as your pivot, or you can choose your pivot randomly. It's a different implementation, but here I've decided just to make it simple, take my first element in the array as my pivot. So that is A0 as my pivot, which is the first element. So I perform a partition on this array on my pivot. What does the partitioning means? It means that I sift through the entire array, and all the elements that are less than or equals to my pivot, I'll put them on the left, and all the elements that are greater than, strictly greater than my pivot, I put them on the right. That's just simple. So by doing so, my pivot will be on its sorted position, because I place all the elements that are less than or equal to it on the left, and all the elements that are greater than it on the right. So at the end of the day, 5 will remain on a sorted position, and that's the end of that. So I pick up my left A as if is the initial array entirely, just the same way I did for A. I just do the same thing for my left A. I pick my pivot as the left, and I choose all the elements that are less than the left or less than or equals to. I put it on the left. All the elements that are greater on the right. I continue to do that until I have just one element or no element. Once I'm done with this, I do the same thing for my right, and that's all. So simple. So let's see how that is done. This is when you pick our left element A, the left array, and we pick our first element here as 3. So this is a recursion tree of our partitioning. So what happened in our partitioning, we have our initial array. We divide the array into two parts based on those that are less than or equal to and those that are greater than our pivot. Our pivot here is 5, so everything here is less than or equal to 5, everything is greater. So we'll undo the left part of our tree. Our partition, our pivot here is 3, so we'll partition on 3, everything less than 3 is here, and everything less than or equals to 3 here, everything greater than 3, we'll put it here. Or you might decide to put your 3 here, whichever way you want to, but the intuition is everything less than your pivot on one side, everything greater on the other side. Here our pivot here is 1, everything less on this side, everything greater on the side. So we do the same thing here. So that's what we have for our partitioning. So if we want to do an analysis of running an algorithm on that and this, so we can just do that, and let's see how that runs on this sample. So I have initially 5 3. I have initially 5 3 1 9 8 2 4 7. So when we're implementing algorithm, quicksort algorithm, let's see how we can achieve this with our code. So the intuition is to be able to do partitioning, because the major work in quicksort is the partitioning. So the intuition is to achieve partitioning, we can put 2 variables. We put one index variable to start at our low, and we put another index variable, call it j, to start at our high. Then we increment our high from this place, from the left part. We keep incrementing it, it keep moving to this place, to this place, to this place. We keep incrementing our I, and our j, we keep decrementing our j. Each time we increment our I, we first check whether the value of the index I, or the element that is at index I, whether it is less than or equals to our pivot. If it is less than or equals to our pivot, we don't do anything, we move to the next one. We check again whether it is less than or equals to our pivot. If it is less than or equals to our pivot, we don't do anything, we move on until we get to a point where the element is greater than our pivot. Then our I will stop at that position. Then we go to our j. Our j will be checking whether the element is greater than our pivot. Once the element is greater than our pivot, and the element at index j, if it's greater than our pivot, it continues to decrement. It checks again whether the element is greater than our pivot, and once it encounters an element that is not greater than our pivot, then it stops. Then once we get to that position, I has stopped, j has stopped, then we check at that stage whether I is still less than j. I mean the index of I, whether it's still less than the index of j. If it is still less, then we swap the position of the two. But if the index of I is now greater than that of j, that is no longer less than j, then that means I and j have crossed. Then what we do is that we swap the position of j with our left, which is with our pivot, with our left, the first element, and that position will be the partitioning position. That is the intuition. So I will just try to walk through that using this. So let's see how we can walk through that. Here my I is equal to 0, my first index, and my j will be equals to the number of the size of my array. Here the size of my array is 8. Okay, but because I am starting my I at 0, then I cannot put my j as 8. I need to put my j at 7. I need to subtract 1 from my j, from my 8, to get 7 from the size of the array, so that I won't run into array index out of band error. I hope you understand that. So my I equals to 0 and my j equals to 7. So I'll go into a loop because I'll continue to do this for the entire array, for all the elements in the array. So I check my I whether it is less than j, which is so in this case because 0 is less than 7. So I enter into my loop. I enter into a loop. Then what do? I take my a of I, that is a of I, which is 0 because my I is 0. So my a of I equals to 0, a of I, which is a of 0, and the element that corresponds to that is 5. Then I check my a of j, which is now 7. The element that corresponds to that is, fortunately, is also 7. Okay, so what do? I have my a of I, which is 0, which is 5. So I check with my pivot. So what is my pivot? I've decided that my pivot is the first element. So the first element is a of 0. So my pivot in this case is 5. So I do a comparison between a of 0, that is a of my j, and my pivot. Is it less or equals to, is a of I, is it less than or equals to my pivot? Yes. So what do? I increment my I. So my I goes from 0 to 1. So the new element becomes 3. So I check again, is a of I, which is 3 now, is it less than or equals to my pivot? Yes. So I increment my I, it turns to 2. I check again, is a of 2, what is my a of 2 now? My a of 2 is 1. Is it less than or equals to my pivot? 5. Yes. Then I increment my I again, it becomes 3. And what is my a of 3? A of 3 now is 9. So my a of I is 9. Is 9 less than or equals to 5? No. So I stop. Then I go to my a of j. A of j is 7. And I check, is a of j, which is 7, is it greater than my pivot, which is 5? Yes. So I decrement my a of j from 7, then it becomes 6. You remember its index is 7 initially. Then it becomes 6. Then I check my a of 6, which is my a of j. Now the value is 4. Is 4, is it greater than my pivot 5? No, it is not. So at that level, I am going to swap my a of 3 and a of 6. That is my a of I and my a of j, because my I is still less than my j. 3 is still less than 6. So I'm going to swap my a of I. So my a of I is what? Is 9. So I'm going to swap it, then it will become 4. And the element at my a of 6, which is 4, it will become 9. Okay, so that's the first one. Then I continue. Now I'm in a of 3. Now my a of 3 now is now equals to 4. And my a of 6 now is now equals to 9. So I check my a of 3, that is my a of I, is it less than or equals to my pivot, that is 4, is it less than or equals to 5? Yes. So I increment my a of I, it becomes 4. So my a of 4 in my array is 8, because 0, 1, 2, 3, 4 is 8. Then I check my 8. Is it less than or equals to my pivot 5? No. So I stop. Then I go to my A of 6. I check. What is my A of 6? 9. Is 9 greater than my pivot? Yes. So I decrement my A of j. It becomes 5. And what is my A of 5? That is 2 in my array. So I check. Is my A of j, which is A of 5, which is 2, is it greater than my pivot? No. Then I stop. Then once I stop, I check if my I has not crossed j. That is my A of my I less than j? So is 4 less than 5? Yes. Then I swap. So it means I swap my A of 4, it will become 2. And so this becomes 2. And my A of 5 becomes 8. So my A of 5, this one becomes 8. Okay? So I continue again. I check my A of I, which is A of 4, which is 2. Is it less than or equals to 5? Yes. Then I increment my I. It becomes 5. And what is my A of 5 now? My A of 5 now is now 8. We check 0, 1, 2, 3, 4, 5. Is now 8. I check, is my 8 A of I, is it less than or equals to my pivot, which is 5? No. So I stop for I. Then I go to my A of j. My A of j is 8. Is my A of j, which is 8, greater than my 5? Yes. Then I increment my A of j. Then it becomes 6. And the value of A of 6 is now 2. Is my A of 6, which is my A of j, 2, is it greater than my pivot, which is 5? No. Then I stop. Then I check my I and my j. I check my I and my j. Is my, oh sorry, this one was made a mistake there. This was this is 7, this is 6, this is 5. So my A of j becomes 4, not 6. It becomes 4. So my A of j was 5 before. This is 7, this is 6, this is 5. It was 5 before. Now is now, because it's decrementing, it becomes 4. So my A of 4 is 2. So it's my A of 4, which is my A of j, is it greater than pivot? No. So I decrement j, it becomes 4. So at that level, I stop and I check, is my I less than my j? No, 5 is not less than 4. Then I exit the while loop. Then I swap my low. What is my low? My low is 5, which is my pivot, with my A of j. So my A of j, my low becomes my A of j. My A of j is 2. So this is 2. And the position of my A of j, the position of my A of j becomes my A of low. So this is my position. It becomes 5. This is the partitioning position. So I return this position, which is my j. This is my j position. So here it will be 0, 1, 2, 3, 4. So I return 4. So these will be partitioned into this. So at this stage, I have my partitioning. So this position is sorted. So this is partitioned into 2 halves, this and this. Okay, so that is what I have for that. So that becomes sorted. So I do the same thing on this part. So I do the same thing on this part. I check my I is starting from here, 2. My J is starting from here on 4. I continue to check is 2 because my pivot now becomes 2. Is 2 less than or equals to my pivot? Yes. I move on. 3. Is 3 less than or equals to my pivot? No. 3 is not less than or equals to my pivot. I stop. So I come here. 4. Is 4 greater than my pivot? And my pivot is 2. Yes. Then I come here. 1. Is 1 greater than my pivot? No. So I exchange my I and my J. So this one becomes 1. And this one becomes 3. So I continue to check again. Is 1 less than or equals to my pivot, which is 2? Yes. Then I increment my high. It comes here. Now I check. Is my 3 less than or equals to my pivot? No. I stop. Then remember that my J was here. So I check. J, is 3 greater than my pivot? Yes. So I decrement J. Comes here. Is 1 greater than my pivot? No. I stop. So my J is here. My high is here. They have crossed. So because they have crossed now, because I is no longer less than J, so I've gotten to my pivot position. So my J is here. So I swap the position of my J with the position of my pivot. So this becomes 2 and this becomes 1. At that stage, my pivot is sorted. So this is sorted. The position of my J is sorted. So this is sorted. So this is sorted. This is sorted. So I do the same thing on this because this one is just a single element. So a single element is sorted. So this remains sorted. So this and this are sorted. Then I do the same thing on these two elements. My I will start from here and my J will start from here. So I check my pivot is 3. Is 3 less than or equals to my pivot? Yes. Then I increment I. Is 4 less than or equals to my pivot? No. So I stop there. Then I take my J, which is starting here. Is 4 greater than my pivot? Yes. Then I decrement my J. 3. Is 3 greater than my pivot? No. Okay. So my I is here. My J is here. So my I is no longer less than J. They are crossed. So I swap my J with the pivot. And the position of my pivot is 3. And my J is also in 3. So the swapping is the same. So this and this is sorted. So they are sorted. This is sorted. Then I come to this side. My high is 8. My J is 7. The position of my pivot is 8. Is 8 less than or equals to my pivot? Yes. I increment my I. Is 9 less than or equals to my pivot, which is 8? No. So I stay there for I. Then I go to J, which is 7. Is 7 greater than my pivot and my pivot is 8? No. So what do? I check if my high, which is 9, is less than the position of my I, is less than the position of my J. Yes. So I swap my high and J. So I swap the element. So this is 7 and this is 9. So I've swapped the two elements. So my I is here and my J is here. So I continue to check. Is my I, which is 7, is it less than my pivot? Yes. So I continue. I get to 9. Is 9, is it less than my pivot? No. So I stop there. So, and I check my my j is here, so I compare my j with my pivot. Is 9, is it greater than the pivot? Yes, so my j moves here. So is 7, is it greater than my pivot? No, so I stop. So my j is here on 7, my I is here on 9. So I has crossed j, so I exchange the position of my j with my pivot. So this becomes 7 and this becomes 8, and so this is sorted. And so that is Quicksort. So let's see the implementation in Java. Just what I've walked through is what we implemented there. So these are Quicksort. It receives the array, the low, and the I. So the low is 0 and the I is the size of the array. So we check if our low is less than I, and we call partition on the array with the low and the I. Then we recursively call this same method, Quicksort, on the array from low to high. Technically this is from low to I minus 1, because since we're starting at 0, then we'll be stopping at high minus 1. So this one too we call from high plus 1 to high minus 1, because we are not going to reach this I. It's going to stop at 1 less than the last value. So we call Quicksort recursively on each left part. And this is our partition. So these are partition, these are pivot. We take it as our low, and we get our I and j. So our I is low. See that our j does not reach I, so our j is 1 minus, I minus 1. So we're taking 1 from our I, because we'll run into index error if we don't do that. So while I is less than j in our array, so we continue to iterate through. Then we check the value of ai. Like we said, if it's less than or equals to pivot, we increment our I. Then once we're done, once that exits, once this becomes false, then we move to this place. We continue to check our a of I is greater than our pivot, we decrement j. And once this becomes false, we check if I is less than j, then we swap the values. Then we continue until our while loop, until we get to the end of our while loop. And after we get to the end of our while loop, we swap our j with pivot. So we swap our j with the value of the pivot, which is our a of low. So our a of low is swapped with the value of our a of j, so that the pivot can be sorted, can be placed in its right sorted position. Then we return the position of that pivot, which is j, and that's all. You can see the code on my GitHub page. The analysis time and space, like I showed us, this the partitioning is partitioning the element of the array into 2 equal parts, provided we are lucky to have a good pivot. Since it's doing that, so our partitioning is going to take order corresponding to the height of the tree, which is log of n. And since we are iterating through the entire array, since we are going through it with our while loop, since our while loop is going from 0 to the length of the array, so this is going to run in n times whatever our partition procedure gives us. So since we are calling partitioning, so it's going to run in n times that the number of times that our partitioning is taking place. So the constant space, we are using a constant space and is in place. We don't use any extra space. Thanks for listening. Your comment are appreciated. If you don't mind, I can do a quick demonstration of the code that we have uploaded on GitHub. And so you can just look at it. This is the code we have uploaded on our GitHub page. So the full implementation is there. And you can just run the code and just do a quick check for you to see what we have there. So if we have these elements that like we have here, we have this element, we can just run it and just do a Java and do a Java. So you can check through and you see that it gives us a sorted array because we are starting with 539, so we have 359, and you can decide to use this other one and you use that, you run that, this and this, so you can check what it gives us. So you can see we have 1 1 2 3 4 5 7 8 9. Thanks for listening. See you in another tutorial.